All right, so let's start with partitioning. Now, partitioning is not a unique concept to Iceberg. Partitioning has existed in lakehouse tables going back many, many, many years. Fundamental process of organizing rows of data that are often queried together within a consistent set of files, right? I've been corrected on this sub-bullet many, many times, but the way I like to think of partitioning is it's kind of like indexing for lakehouse tables. If you translate this to like the oracles of the SQL servers of the world or some of the legacy kind of databases that have been around for a long time, if you wanted data to be grouped together for efficient querying, you would build an index on that data. And instead of having to query the entire table, you could run queries against an index to more quickly retrieve information. And fundamentally, partitioning offers the same types of capabilities for lakehouse tables. Now, one of the easiest ways to maybe visualize partitioning is specifically when you look at like a Hive table as an example, and you write data into a partitioned Hive table. Partitioning actually defines the folder structure of where the data files sit. Those of you that have used like Athena to query Hive tables, if you actually look at S3 behind those tables, you'll see folders mapping to different partitions based on how you've configured the data. So that when you go and query that table, assuming you query by the partition column and the partition keys, instead of Athena or whatever the query engine is having to query the entire table and scan every file, it can go straight to only the partitions needed and scan a much smaller volume of data, right? So that's just partitioning 101. Now, lakehouse tables, going back many years, specifically if we consider Hive, and I'm going to do a couple comparisons to Hive as we go through this session. This isn't necessarily meant to be an Iceberg versus Hive conversation, but I think by comparing it to Hive, which is, was the standard for lakehouse tables and still is a standard that many customers are facing, I think it gives some interesting comparison points to talk about some of the uniqueness of Iceberg. Within Hive tables, though, I've seen it described as explicit partitioning. So when you create a Hive table, you explicitly define the column that you want to use for partitioning within that table. A very common example, I want to partition by date, right? So a day, for example. And each day's data is going to go into a unique Hive partition. And so that's the reason why we call that explicit partitioning is you are specifically defining the partition column when you create the table. And when you write data into that table, you have to explicitly map each record with a partition key that follows the partition column, right? In other words, there's a bullet there, partition keys are not validated. If you're partitioning in Hive by a date, and you try to write a timestamp into that date column, at worst, that data might be put into an incorrect partition. Sorry, I should say at best, which means the data could be lost or not really referenced in queries. But sometimes that data is just lost overall because you're writing into an invalid partition, right? The other challenge with this explicit partitioning is when you query a Hive table, you have to explicitly query by the partition column, right? If you've got a year's worth of data in a Hive table that's partitioned by date, and you only want to return data from the last 7 days, you have to explicitly put a where clause on your query that queries by partition date. And in that where clause logic, you have to construct it as such that the partition keys match exactly the partition values that are within those partitions. Right? And if you don't do that properly, then you could either query the wrong partitions or you could scan the entire table when you only need 7 days worth of data. Another consideration with explicit partitioning is that if you want to modify the partition scheme of a table, that table has to be completely rebuilt and all data has to be rewritten, right? This explicit partitioning that was commonplace in lakehouse tables, it actually defined the layout and the structure of where files are stored. And so to change the partitioning of a table is to fundamentally change the way that data is stored, which means you have to rewrite the data when changing partitioning. So it's very expensive. It's a very complex operation should you need to change partitioning. And that's a big consideration. We talk to customers all the time that have been writing data into tables for the last few years. They've been using daily partitions, and now they want to consider a different partition scheme. There's really no way around. Changing Hive partitioning is effectively starting over and rebuilding the table using the new partitioning scheme. So Iceberg introduces kind of a unique concept around partitioning. It's referred to in a lot of the documentation as hidden partitioning. And the reason why I call it hidden partitioning is it's much less explicit than Hive partitioning. Within Iceberg, the partitions are defined as a table configuration, right? So, and I'll show you an example of what this looks like here in a few minutes, but effectively you define partitioning as a table configuration, including, for example, some transformation logic that takes some source data and maps it into a partition key. And then Iceberg handles the process of producing a valid partition value based on that configuration, right? Remember, in Hive, if you partition by date and tried to write in a timestamp, probably wouldn't work, right? In Iceberg, you could partition by day, write a timestamp into that table, and Iceberg would handle converting that timestamp into a day that it can then partition by, right? So that's a much easier way to apply partitioning to a table. Another real nice advantage of this partition method is that partition columns do not need to be explicitly referenced in queries, right? So again, you could partition by day, and in Hive, you'd have to query by day. In Iceberg, you could query by timestamp, and because Iceberg understands the way that those partition keys were mapped, it can generate an efficient query plan, even if you don't query by the exact partition keys that are being retrieved. Another real nice advantage to this partition methodology is that you can change the partitioning within an Iceberg table. So if you're writing into a table that's partitioned by day and you decide after the fact, maybe after you've been writing into that table for 6 months, that you want a different partitioning scheme, maybe you want to partition by hour, you need to partition by account ID or something like that, you can change the partitioning of a table. Partitioning configurations are maintained in those metadata files that I alluded to in the fundamental discussion. And so you could change the partition of an Iceberg table, and then any new snapshots created within that table will adopt the new partition scheme. Now, there is a big caveat to this that can have some fundamental impact on Iceberg behavior. And sometimes this is an afterthought. When you change the partitioning of an Iceberg table, which again is possible, it's not possible in other table formats, but is possible in Iceberg, that's only going to apply to new data that's written into that table. All right, so if you've got 6 months worth of old data and you change the partitioning scheme, the old data by default will not be rewritten. Only new data will be written into the new partition scheme. Now, there is an Iceberg command. There's a set of scripts that you can run to rewrite an Iceberg table based off of a new partition scheme. But unless you do rewrite the data, changing the partitioning will only apply to new data that's written in. And that's something that does need to be considered if you're going to take advantage of this ability. So just a real quick example, there's a really good Dremio article, which I actually link to later in the session on, and shout out to Dremio. There's a lot of really good content on Dremio's website about Iceberg. And so I definitely recommend you take a look at some of their content if you're interested in learning more. So with partitioning in Iceberg, you'll see a create table statement over there on the left. And that's a way that you can create a very simple Iceberg table. And you'll see partitioned by, notice we're first partitioning by level, and then we're partitioning by a function that's applied to a timestamp, right? This would not have been possible in Hive partitioning. In Hive partitioning, you have to partition by an explicit column, and then you have to write valid partition keys into that column. And it's really up to the writer to make sure that those keys are valid. right? If you try to insert data into a Hive table with a partition key that's not valid, the data could either be written into an incorrect partition or it could be discarded altogether because it doesn't match the partitioning configuration. Whereas you'll notice over on the right, when you insert into an Iceberg table, you insert the level, which is a string. That part is fairly easy, right? But then you can just insert a timestamp, and notice those timestamps have second precision, right? It's a timestamp down to the second. But Iceberg will then handle mapping that timestamp into a valid partition key, which is a day, and then use that day to partition the data, right? So that's really, it's very simple, as it's described, but it's a fairly unique concept in lakehouse architectures, and something that's fairly unique to Iceberg is this ability. And when we talk about kind of advanced techniques, the nice thing about Iceberg is honestly, this isn't that advanced, right? It's just something that you can do within Iceberg that I shouldn't say guarantee, that improves the impact that partitioning has on query performance, right? It takes a lot of the burden of partitioning off of the writer and the reader and puts it on the table configuration to ensure that data is being partitioned, and ensures that data being written into the table and data being queried from the table can take advantage of that partitioning. A couple questions here that I've gotten about documentation and slides and scripts. Absolutely, the slides will be made available. I'll also send out some links to reference material that I use to create some of this content, and the content's being recorded. So don't worry about taking notes or taking screenshots. Everything that I showed today will be available after the session.